Today's lesson is actually a little bit short. It's section 11.5, graphing logarithms, and it's actually a review of your last lesson. So the first part is change of base. Change of base says they want you to solve it. For me, I just set it equal to x or set it equal to y, and then I say 2 to what power is 8? Well, I know x is going to equal 3. So 2 cubed is 8. Done. Now, if you get a weird one where it doesn't have like a nice number, like if this had been a 9, well, then you do what's called the change of base. So change of base says you set it equal to log of 8 divided by log 2. And you're just going to type that into your calculator, log 8 divided by log 2. And you get your answer. Okay, so you can either think about it or just use your calculator. And that's going to be like these types of problems here for your homework. The next part is going to be solving, and solving you'll have the same way as we did last time. And then also graphing logarithms. Graphing logarithms, we know that y equals 2 to the x looks something like this. And the inverse of that is y equals log base 2 to the x. Would look something like this. All it does is it takes all these points and switches it. So if this is the point 0, 1, then this is the point 1, 0. If this had been the point, let's see, 2 cubed, so 3, 8, then this is the point 8, 3. And you're going to go ahead and graph that. Now, my graphs won't come out as nice as they are on here, so I'm going to show you on here. So first one you want to do is this one. You're probably going to have 5 graphs on your papers. The first one says, your basic one, log base 2 of x. All it does is it takes these graphs and inverts them. And as long as you kind of know the general shape, that's fine. And again, you can always use Desmos to get an accurate graph or get a table of values for that. That's about 8, 3 right there. Okay. Now the next one is minus 4. What is that minus 4 going to do to your graph? So this was your original one. And what does that minus 4 do to your graph? Oh, okay, it shifts it to the right 4, the opposite of what you think. Okay, same with all your other functions. So it shifts it right 4, and so that's your new function. Go ahead and graph that. You can do it on the same graph as if you want, or a new graph. So x log base 2, x minus 4 just shifts it right 2. Oh, and if you're entering these on your Desmos, it's y equals, and you go to functions, and you go to miscellaneous, and it's going to be, log is naturally base 10, but you're going to do the one with this one, so you can put in a different base. Okay. Now you don't have to do this next one. It says y equals log x plus 4. What does the x plus 4 do to your graph? Yeah, it's going to take it, instead of moving it to the right, it's going to move it to the left 4. It's the opposite of what you think, right? Okay, and then the last one, the plus 4 shifts it up 4. And if you had a minus 4, it would shift it down 4. Okay. All right, let's go back to this one, and we're going to change. Yeah, let's change that one. Let's say that I added a 3 in the front. Well, what is a 3 going to do to your graph? We know that the minus 4 took this one and moved it over 4 units. But a 3, what would the 3 do to your graph? It's actually going to make it 3 times as higher. Go ahead and graph that one as well. So normally this would have crossed, let's see if I can get this, at 0.5 on this one. And if you take a point over here, let me find a point. Okay, so we can see that this is the original y equals log base 2 of x. This is a 0.83. So when it got shifted over 4 units, so this is going to be 13.3. Y equals 3 log base 2 of x minus 4. In this case, this is going to be about 3 times as high. So this should be about 3 times as high. Again, if you had a fraction in front of there, 1/3 or 1/2, it would make it 1/2 as high. So you should go ahead and graph this green line and just making it 3 times as high as this one. And again, if you did a 1/2, you know it's going to make it about half the size of this. So normally it was at 3. It looks like it's about halfway up. And again, that's how that's reflected. Play around with Desmos if you guys need help with that. Okay, the last one that you're doing is this problem right here, which says solve by graphing. So I did problem 55, solve by graphing. What you're going to do is just plug it into Desmos or graphing calculator, and you're going to set up 2 equations, 8 to the 2x plus 1 and 30 equals 4. So, oops. Oh, I had it done. Hold on, let me go. Okay, so what I did is I entered one equation, and it was 8 to the 2x plus 1. So whatever's on the left-hand side, you're going to enter it. And then you're going to enter whatever it's equal to on the right-hand side. And then you're just going to play around with your graph. And then you're just going to try to see where they intersect. So I can see that they intersect at 0.321, 30.4. So then my answer for that one is 0.321. I think just flipped. All right, and that's it for the graphing. So play around with the same rules as last time, and then use your Desmos to kind of see what that graph looks like, how it changes. But it's the same as those other functions.